So let's begin with, we have talked about this on Thursday. So we have a rotating axis. So suppose, let's say we have, let's say we have a line here, and then we rotate this line about this axis, and we can get a surface area of surface or surface area. Surface, oh wait a minute. Surface 是表面哈 surface area. We can get the surface area by if we know the length of the line and we know the centroid of the line, we can determine its surface area. So in this case, we determine the length of the line and we determine the distance. We determine the distance traveled by the centroid. So the centroid is here, that it rotates by one cycle or one revolution. One revolution here. So, and the area is equal to the length of the line times 2 pi times y bar here. And the same can be used to determine the volume from area. So if we have a area here that it rotates about x-axis for one revolution, and then we can get a volume. So the volume is equal to the area, this one, and times the distance traveled by the centroid. So let's take a look of an example here. So determine the volume and surface area of the chain length shown here, and which is made from 6 millimeter diameter bar. So this one is diameter is 6 millimeter, and if R is equal to 10 millimeter and L is equal to 30 millimeters. So in this case, we have this chain length is equal to one donut shape, but in mathematics we call it torus. So it's equal to one torus plus two cylinders. Cylinder 圆柱. So in this case, how do we determine the surface area? Let's say this is on the left hand side we have A1 here, and then we have the surface area of cylinder is called A2. So surface area A is equal to, remember surface area is 表面积. A is equal to A1 plus 2A2 because we have two cylinders. One cylinder on the left and one cylinder on the right. So we have one cylinder on the left and one cylinder on the right. So we have two cylinders, and we have one torus. Of course, you can say it is equal to 2 times half of A1, but you know what I mean here. Of course, we have half of it at the bottom and half of it to the right. So you can have half of it to the left and half of it to the right. So, but this one is the result. For A1, of course, you know how to calculate A2, but how about A1 here? For A1, that we need to, A1 is equal to, let me repeat the equation here, L times 2 pi y bar here. So what is L? L is the length of the line. Here, this is the length of the line L. And the axis of rotation is in the middle. So the axis of rotation is here. And sorry, where's the centroid of this circle? It is at the center of circle, right? This is the centroid of the circle. Center of circle is here. So we have y bar here. So this area is created by rotating this line by one revolution, and then we get this torus. So this is the distance traveled by the centroid. So this is 2 pi y bar. And what is y bar here? Y bar in this problem is how much is equal to this is equal to R, which is equal to 10 millimeter, and this is L is equal to because the diameter is 6 millimeter, so it is equal to 6 millimeter times pi, right? And it's okay. So this y bar is equal to R here. Y bar is equal to R. So we have y bar is equal to R here. And for the question says this is 6 millimeter diameter. So the circumference is 5 times 6 millimeters. I think I have told you circumference is 圆周哈。So this is A1, and for A2 is equal to 2 times equal to 30 times 6 times pi, because this is should I say put it L here? L, and L is equal to 30 millimeter. This one, right? Good. So let's have a right. So how about I probably write like this one, that pi times d. Okay, pi times d, and d is equal to very good suggestion. And okay, d is equal to 6 millimeter. And this one is equal to d as well, huh? 因为我这边就刚同学提醒我，就是第一是那个应该这两个 L 会重叠了，所以这一条线的长度是派乘以 d 这样子。那这个也是 d 乘以派乘以 d 是那个这一个的直径，或者是这一个直径，对吗？ So, and the result would be this one. This is we get the surface area like this. Oh. The same thing can be done for volume, but take your time to write write this part first. And for volume, that we can do the same. V is equal to V1 plus V2 V2, and V1 is equal to the volume of this torus. Let me make it smaller. And V1 is equal to the volume of this torus. Then how can we get the volume of this torus? So it is the area of this circle times the distance traveled by the centroid. So from an area, we rotate by one motion, we can get a volume. So this is we get the area here, and then we multiply the area by the distance traveled by the centroid. And for cylinder, you know how to calculate the volume of a cylinder, right? So V1 is equal to A times 2 pi y bar, which is equal to this is and this is A, and this is y bar. And of course, V2 is equal to pi over 4 times 6 millimeter squared times 30 millimeter. And therefore, the total volume is this one. These are the answers, and the key point in this problem is how to use these two equations. So we are on page 58. I'll give you some exercises this week to practice on these two equations. Now, take your time. So I will, after you have finished this, then we go on to the next page. One of your friend has asked a very good question. So for this A is equal to, and this surface area, this A and this A are not, they are not the same. They are not the same. This is this A is the surface area of the whole. This A is the surface area of the whole chain. This surface area A is equal to the surface area of the whole chain. And for the A here, this one is how to generate the volume here. So this the A below is the A here in the cross section. So here is the A here, and then we get the volume from area. We get the volume from this area. So the A below is this one. Very good question. Let me mark it down, and So if all of us are okay, that most of us are okay, then we go on to the next page, and we go on to with 3 dimensions. So this one is let's say we have a pyramid here. Pyramid is what is a pyramid? 金字塔啊。The weight is W. And we have a ball and socket joint at the origin. I'm not sure whether I've told you that this is called origin. No, should I just write this way? So we have a pyramid and we have a ball and socket joint at origin. That it cannot move. It cannot move in X, Y, or Z directions, but it can rotate. It can rotate in all directions, but it cannot move. It cannot move, but it can only rotate. So the weight is W. So we want to get an equivalent system like this one. With so the total moment of this pyramid is equal to this point mass. And this one is the distance is 6 pounds. So this is the center of gravity, center of centroid here. So let's write it down in this way. So X, Y, and Z. This is Z. So in this equation, on the system on the right, of course, the moment is equal to X bar times W, right? Or I would say we use cross product. And how about on the left? On the left, we have dm is equal to, for a small area. For a small area here, we have dm. How do we get dm here? For the moment of this small slice. For the moment of this small slice, how can we get the moment? dm is equal to moment's arm times weight. So this is X bar time cross dw. So the moment of the whole block is integration of X bar times dw. But this is the idea of this X bar. Now, for 3D problems that I don't need you to memorize. I don't need you to memorize the location of centroids, but I will give you equations without explanation. In examination, so I will in examination, if I need this x bar and volume, then I'll give them to you, but I will just write down the equation. But for simple shapes like this and this, like a cylinder, that you know how to calculate this. But for these two shapes, that I'll give you the equations. I'll give you these equations, but I will not explain them. It's okay.